So when we say isotopes, these are atoms of the same element. With different masses. So, and isotopes have different numbers of neutrons. Okay, different numbers of neutrons. Thus, different mass numbers. Example, carbon. So carbon has these isotopes. Okay, they have different masses. So the same number of protons, it's the same element, the same atomic number, the same number of electrons, but different number of neutrons. Like, okay, we can call this, okay, these are the isotopes of carbon, so you can call this, the first one as carbon 11. Next one is carbon 12. Next one is carbon 13. Next one is carbon 14. Yeah. So carbon 11 has a mass number of 11. Carbon 12 has 12. 13 has 13. And carbon 14 has a mass number of 14. Okay, take note. The same element but different mass. What else? Also, yeah, I'm not sure if it's included in your lessons. Not yet. Fractional abundances, relative abundances, like calculating the average atomic masses. Not yet. Yeah, that would be the next lesson, I think. So you'll be calculating the atomic mass or average atomic mass or weight. So you have atomic and molecular masses, and you get ratios of those. And well, maybe I can just discuss here the average atomic mass or atomic weight. Okay, so for atomic weight, is just equal to the summation of the product of the fractional isotope abundance, times the mass of the isotope. So say for example, for okay, we'll do carbon or maybe chlorine. I have chlorine here. So naturally, say for example, this problem, naturally occurring chlorine is 75.78%. Okay, then chlorine 35 is 34, has a mass of 34.969 atomic mass unit, and is 24.22% in abundance. And then for chlorine 37, okay, its mass is 36.966 atomic mass unit. Okay, calculate the average atomic mass. So we calculate the average atomic mass or atomic weight. This is just, we just multiply. Oh no, this one is 70. Why did I do that. I misinterpret it. So the chlorine 35 is 75, its abundance is 75.78%. 37 is 24.22%. Then we just add them up. We multiply the percentage. We convert this first to decimal. So that is 0.7578 times the mass of chlorine 35, which is 34.969, plus we convert this to percentage, to decimal, divide by 100, so this is 0.2422 times the mass, which is 36.966. Okay, you calculate that with your calculator, yeah, then you get 35.45 atomic mass unit. So now this is the average atomic mass of chlorine, of the given two isotopes of chlorine. You got that? What else? Confusing? Alright, which part there is confusing? Okay, so you're given the isotopes. You now know the definition of isotopes, right? So the same element but different mass number, right? Okay, and those isotopes, they occur in they have this percent abundance. Like say for example in this case, so we have two isotopes for chlorine, chlorine 35 and chlorine 37. So it says here that chlorine 35, its percent abundance is 75.78%, while the chlorine 37 is 24.22%. So that means the isotope of chlorine, which is chlorine 35, is more abundant than chlorine 37. Then these are the individual masses of each of the isotopes. Now we are in the problem, we are asked for the average atomic weight or atomic mass, average. And this is the formula in solving the average atomic weight. You just add up the product of the fractional abundance. Fractional meaning you convert the percentage abundance into decimal, and then you multiply it by the mass. So we're given the mass here of each of the isotopes of chlorine, and we're given the percent abundance. You just convert this to decimal by dividing it by 100. Now you got it? Yeah? Do you want me to give you a problem? You just take note of this. Okay, take a screenshot of that and let me delete this. I will give you another problem. Okay, let's try neon, rhenium, or maybe rhenium. Oh no, rhenium. Oh no, this one, neon. I will delete, okay? Yeah, neon. Okay, neon has 3 naturally occurring isotopes with the following masses. So we have neon 20, and its mass is 19.992 atomic mass unit. So that is the mass. Or maybe I will just put here so you won't be confused. So for neon 20, its mass is equal to 19.992 atomic mass unit. Then for neon 21, its mass is, okay, I will also put the percent abundance. Percent abundance for percent abundance is 90.48%, and for neon 21, its mass is equal to 20.994 atomic mass unit, and its percent abundance is 0.27%. And then the third isotope of neon has a mass of 21.991 atomic mass unit, and its percent abundance is equal to 9.25%. Okay, now calculate the average atomic weight or atomic mass. Okay, you want to try that? Okay, for neon 20, you multiply 19.992 times this one. You convert this to decimal first, divide by 100, so this is 0.9048 to get rid of the percent. 0948, then plus this one, 20.994 times, you convert that one to decimal, 27. All right, then the next one is this one, neon 22, so that is 21.991 times 9.25 divided by 100, 0.925. Okay, then you use your calculator to solve that. What did you get? Alright, okay. You do it like one by one, but don't round it off yet. You only round off the final answer. Okay, we got the same answers. So that is 20.1796. That's what I got too. So that is the average atomic mass of the three isotopes of neon. And chemical formulas. I'm sure you will do chemical formulas, how to write formulas of elements and compounds. Yeah, notations, Lewis structure, skeletal formula, condensed formula, you'll be dealing with those. Should know about diatomic molecules, and then types of formulas, molecular formulas, empirical formulas. And you'll be that one is also calculation part.